Okay, so question 12, we are doing a scheduler, some components of the scheduler. We have our enum day class, which will come in handy later. We're going to need a time object that wraps up the hour and the minute, and how we're going to increment all that with some operator overloading and doing all the logic of subtracting and adding with hours and minutes, as that can be tricky. We wrap that up also now into a time object with a day object into a class appointment time, where we're going to use operators to then traverse our link list to insert appointments. So we get to our doubly linked list. We have a destructor because that's important. And then we have a forward empty slot, which will determine some information in a minute, a backward empty slot. Insert appointment, traverse the list as normal, edge cases if we need to reassign head. And as we are coming through the list, if we find an appointment time is no longer greater than the what's on the schedule, we want to test it for overlapping. Real cool part of the logic here. So now we have to determine if we could move forward in the list versus backward in the list, where's the nearest node that kind of is closest to what was currently going to be scheduled. In doing all this, a lot of interesting part of the logic happened here where we've had to do some arithmetic on these time objects that I was talking about. So if there was no overlap, we come to this part, we insert as normal. Okay, and that's really the crux of that. So I'm just going to run this for you really fast. And I say, yep, John, it's on Monday. Its start time is at 10. End time is at 11. Yes, Mary, and Monday, and 10, and 11. And we don't want to do anything else. And I just want to point out that this has been sorted correctly, and we moved her along. There we are.